Last time we had introduced the concept of measurement, how we always read between the lines and get all the digits we're sure of and one with some uncertainty. And we had introduced the idea of significant figures and how we use those to tell how well we can measure something. So now we'll talk about the percent concept. And percent is something you've been using all of your lives in everyday life. So usually this goes quite smoothly. When we talk about percent, we mean parts per hundred. So 1% is 1 part in 100. And we can calculate the percent of something by taking the mass in grams of the part divided by the mass in grams total of the total sample, and then multiplying by 100 to move the decimal, and that gives us the percent. So that's how most people use it in everyday life. What we do with it in chemistry is just a little bit different. We can use percent as a conversion factor doing the kind of math we introduced before with the factor label or dimensional analysis, whatever you like to call it. So when we think of percent as parts per hundred, we can think that something like 4.7% can be represented as 4.7 grams of the part divided by 100 grams total. Now, since we're thinking of this as a conversion factor, how many significant figures are there in the 4.7? 2. And how many are there in the 100? 1, the way it's written. But how many are there really when we think that this is a definition, that it's 4.7 grams per 100 grams of sample? Is there any uncertainty in this 100? No, because it's a definition. So this becomes an exact number. So the 4.7 has 2 sig figs, but exact numbers have as many sig figs as I want them to. So I can use 2 sig figs in all my calculations. I don't have to round down to 1 because there's no uncertainty here. It's a definition, exactly 100 parts. And then we could also turn this around and say 100 grams per 4.7 grams. So those are 2 different things that we can do with percent. Now, the tricky part is figuring out what you're supposed to do when you read the problem. And you can usually get a clue at figuring this out by looking at what's written and just writing things down. I think I told you last time that I like to read through the problem and just write all the numbers down on the side because then I know what I have to work with. A sterling silver necklace contains 18.5 grams of silver and 1.5 grams of copper. What is the percent silver in the necklace? Well, we know the mass of silver. We know that we have 18.5 grams of silver. And we know that we have 1.5 grams of copper. So if I want the percent silver, I know that percent silver is going to be the mass of silver divided by the mass total times 100. And when I look at the information I have, this approach will work nicely for this particular problem. So I have to figure out the total mass. So when I add these together, I get 20.0 grams total. So now to find the percent, I have the mass of silver, 18.5 grams, divided by 20.0 grams times 100 gives me 92.5% silver. What would I do if I wanted percent copper? Put 1.5 on the top. The mass of copper on the top divided by the total. Okay, so those are pretty straightforward. So let's have you go ahead and do this one with your groups on your board. Now we have some small tables. Let's have those two tables combine and be a group of 3 for now. And everybody go to the boards with your group and find your position half of a board, either on the side or up here.